So when we are looking for Spark, at least we need to answer a few questions why we are going for Spark. So when we are choosing any processing framework, so we consider few things. So whether it is speed enough to process my use cases. So here for Spark, Spark can run up to 100 times faster than your Hadoop MapReduce in some cases. So this is the ideal numbers given by the Databricks, but at least you can see in real time, you can see at least 60 to 70 times faster minimum. Okay, most of the times you can see at least 60 to 70 times faster. May not be up to 100 times in your real-time clusters, because this depends on, I mean, this is same like when any motorcycle manufacturers, they are selling their products, they say it's like their bikes give you 100 kmpl, but in reality, comes into reality, it might give around 60 or 70, right? The same way, under ideal configurations, it can give up to that speed, but depending on your real-time, your Hadoop cluster configurations by your administrators, they might have some trade-offs. They might be allocating some more RAM memory for other resources than Spark or something. So based on all these factors considering, your Spark is still relatively very faster, and you can still get up to 60 to 70 times faster than your MapReduce results. Okay, and it's ease of.
I have one quick question. So in case if you reduce the memory or increase the memory, to affect, because it's everything. I know it is reading from the RAM. By reducing or increasing the memory, does it has any effect?
Of course, yes.
I mean, you mean to say that if you increase the memory, it can be still faster,
yes,
but it can go up to a certain level, right? Even though if you increase the level.
Correct. See, increasing the RAM memory, I mean, will solve your large files processing. If you are processing really GBs and GBs or terabytes of information of data, if you are using that into RAM memory, that time it requires even more huge memory, right? RAM memory. So that time obviously it will improve the speed. Otherwise, it will read chunks and chunks of data into RAM memory. It will load chunks of data into RAM memory, and from there it will process that.
You mean to say that indirectly we are depending on speed is depending on the RAM, right?
Yes, indirectly speed is depending on the RAM.
Okay. Okay, thank you.
Okay, we'll go to those internals, how it gets loaded into RAM, and how it the trade-off works. Like, so these things internals will discuss once we start our actual Spark hands-on or Spark sessions. Okay. This is just a overview for you. Okay. So it's ease of use. The second feature you can say about it. It can be used with many programming languages, like either Java programming language, a Scala language, or if you are good at Python, you can use Python as well. As we saw, some resources are good at Python and some are good at R. You can use all these languages and you can leverage the Spark speed. Okay.
So I have a quick question. When we use the other languages, like I do R, Python, or Java, like if you see Hive or Pig, indirectly it is going to convert as MapReduce program. In this scenario, is it going to convert it as Scala, or at the back end, what exactly happens?
It will not get converted into Scala. It will run that as it is into the Spark core.
independently in Windows
independently.
7.
They have their own APIs available. The Spark, I can say Spark stages and tasks will be there. So they into them they will get converted.
Okay, so it doesn't use any intermediary language, right?
Yes.
Or does it
See,
going to?
there it is not an intermediate language. That is a framework. It will get converted into maps and reduce tasks, right? I mean, it's
Oh,
they
yeah,
run
yeah,
under
fine.
Yarn child. So here also they will run under Yarn chails only. They will run as a Spark stages and Spark tasks.
Okay, thank you.
Okay. And one more thing is like, so I want to take a pass after uh, each topic, not instead of each point or something, because
Okay,
it breaks my flow. Okay.
okay,
Yeah. So I will give you a pass, or like I will give you a break after completion. Let's say if I'm talking about this topic, so there are 5 or 6 points around it. Okay. So if I complete all these things, then I can open for your questions. Thing is, I might forget the sequence or things that coming in mind.
okay, got it. Thanks, you.
Okay. So the next thing is the next feature or the next recommendation why we can go for Spark is its generality, all things in one place. It in one marketplace you can find almost all the processing tools. Like it gives you a stack of libraries. You can write your native MapReduce code with your Spark native programming. You can run your Hive queries or Impala queries using Spark SQL. You can leverage your Apache Storm using the Spark streaming and Apache Mahout machine learning features with Spark MLib. And if you want to plot any graphs, you can use the GraphX. So you can combine all these libraries seamlessly in the same application. So if you set up Spark, you can use all these subcomponents of your Spark ecosystem. You're getting all these places, same like your Hadoop ecosystem. Inside the Spark ecosystem, you can see all these components. So what I'm trying to say is you have a very good tight integration with all these tools, and you can leverage these things. And next thing is, yeah, it can run anywhere, meaning it can run on your local file system, something you have any files on your local disk. Yes, it can process that. If you have your data on your Hadoop HDFS file system, yes, it can read from there. Or if you have on even in cloud or something, your S3 buckets, even from S3 buckets also it can read the data and process. And inside the NoSQL databases also, it can read it from HBase. And for Cassandra also, it has some connectors to read the data from. Okay. And yeah, so it can read from various places. It can read it from your local disk. It can read it from HDFS. It can read from your NoSQL HBase or any other NoSQLs like Cassandra as well. Okay. And so this is reading your data from different locations and processing that data under different distribution processing frameworks. So Yarn is one such distribution from framework, and Mesos is another framework. Either you can run either of these two frameworks, or you can even run your Spark in a standalone mode. Okay. So even though whether you get it or not at this point of time about Yarn, Mesos, and standalone, so at least for now, just make it as an index that you can run in different distribution processing frameworks. Okay. So there is a lot to discuss on about these points. We'll discuss many more things on once we start with our Spark architecture sessions. Okay. So for now, treat it like you can run under different distribution frameworks. Okay. And we can, Spark gives you the advanced serialization mechanisms that can be used with it. Meaning in Hadoop, we use the MapReduce serialization techniques, like it could be either your writables or through the sequence files or any compressed files or optimized files like coRC or something. So there it is more of like similar to Java kind of serialization. It is not that faster. In Spark, it uses the cryo serialization. So serialization is nothing but converting your data into a binary format, storing that data in binary format. And why do we need serialization is, so if you have to transfer data between one node to another node, obviously the data should be in binary format. This is not the limitation of your Spark, not the limitation of Hadoop. It is there from your computer networks concepts itself. In any network, if you have to transfer data from one machine to another machine, that should be in binary format, meaning that should be in serialized format. So for this serializations, in pure Java applications, Java serialization will be used, and in Hadoop MapReduce applications, we use those writables, int writable or double writable, long writable, those things. And those will be used for serializing your data into binary format. And here in Spark, we do have two types of serializations. Either you can use the default Java serialization, or you can go for the advanced cryo serialization, which improves your speed, your data transfer between your nodes even more faster. Okay, so to summarize its features, it is much faster and it provides you multi-language support. You can use Java, you can use Scala, you can use Python, you can use R, and all the tools come at one place. Like you can write your MapReduce programs, or you can write your logic in Spark native. You can write your Hive queries in Spark SQL. You can write your Apache Mahout any machine learning algorithms in mlib. You can plot your graphs with GraphX, and streaming data processing, Apache Storm or something can be replaced with Spark Streaming. So all these things. And it can read it. It can directly read files from your LFS, HDFS, HBase, or Cassandra or anything. And it can run on different distribution frameworks, Yarn, Mesos, or even the Spark standalone cluster. And it provides the various types of serialization mechanisms to even more speed up your processing. Okay, so the Spark has connectivity with the Cassandra, Hadoop, and HBase, all these things. In our course contents, I will show you all the real-time examples. For Spark connecting with HDFS, obviously it will be there. So with the HBase and with Hive, we'll see a lot. Okay. On Mesos, yes, Anand. Let me complete this slide. Okay. Yeah. Let me complete this slide. So our main focus or real-time integrations in our courses will be like Spark with HDFS and Spark with Hive, and Spark with HBase, and Spark on top of Yarn. Okay, so these will be the combinations that we'll most frequently see in our examples during our Spark applications. Okay, yeah. You have Cassandra connector also for Spark. Maybe I can point you to that in case if in your enterprises anywhere Cassandra is being used to that. And if you guys don't have Cassandra knowledge at all, then I can point you to some of the articles in our blog so that you can get a Cassandra knowledge. But others, whoever attended our Hadoop trainings and all those things, they are pretty much comfortable with Apache HBase as well. You can see how the same Java API that we have seen in Apache HBase that can be leveraged from the Spark APIs, or what are the equivalent APIs in Spark for Apache HBase. Okay. Yes, Anand and Mamta.
Shiva.
Yes, Anand.
We learn Impala, we learn all these tools, right?
Correct.
Where does this fall exactly? Because you know, if I use Impala, I get the same things what I achieved on Spark, correct?
From Impala, yes, it's the same thing. See, it is the same thing. See, like whatever you can run with your MapReduce programming, you can achieve it through Spark native programming. Whatever you can run inside your Hive queries, or whatever you can run from Impala shells, the same things can be run from your Spark SQL. Functionality is same. The speed differs.
So this will be still the fastest so far.
Yep.
Than what we have.
Yep. So in your quick start VMs, it might not be the same in case of Impala, because the quick start VMs come with your Impala mode preferences. You can see the default whenever you see the Cloudera's Hadoop installations or setup default configurations, they will try to give as much RAM memory allocated as possible for Impala mainly than any other tools, because they try to market that than any other tools. It's not an open source Impala, but whereas your Spark is open source, it can be used with your Hortonworks also, whereas your Impala cannot be used with your Hortonworks.
But what I'm getting so far is like Spark is one place to shop, right? I mean, one place to go.
Correct.
While you find everything in Spark,
yep,
you will not have to use it. Okay.
Correct.
And the speed is the fastest.
Speed is the fastest. Yep. And the default, the default Hadoop cluster distributions. So the default, I mean, whenever we go for enterprise support from Cloudera, they will be installing our Hadoop and Spark, all those things into our clusters generally. Okay, in your enterprises, the default configurations, it will be more. They will try to allocate more RAM memory for Impala mainly. So even than Spark, but in real cases, like when you need to actually leverage your Spark speed even faster than your Impala or something, so there will be again trade-off, like you need to allocate, you have to reduce some for other services, and you have to increase your RAM memory for your yarn mainly.
Okay. And then lastly, quickly, so if I have Spark, or if I am using Spark, I don't need to go into the Cloudera world at all, right? I mean, I can pretty much do everything from Spark.
Yes. Again, when you are going for Spark, you still need the HDFS, you still need the HBase or these things, right? Where will you store the data?
No, but I mean, that will be all done. I don't have to access the Cloudera command prompts and that stuff, right? I can do everything pretty much from the Spark front end.
Correct. I mean, I'm trying to ask you that. So you have, this is a processing engine. Apache Spark is a processing engine. This is also a processing frameworks, right? So where does the underlying data get stored?
So that will be in HDFS, correct? That will be in HDFS.
HDFS or HBase in real time, right? So if that is the case, again you should go for either Hortonworks or Apache Hadoop or Cloudera Hadoop, right?
Right.
Okay, so that's why people sometimes will be under impression that it's a competitor. Spark is a competitor for Hadoop. Once Spark comes, Hadoop will no longer be there. Okay, so that's a myth. It's not like that. It's one another add-on tool to your Hadoop ecosystem. Okay, your big data processing tools. It will never replace your entire Hadoop. It can replace at max MapReduce. That's it. And Hive also, I can say it cannot remove or it cannot replace Hive. Thing is, it still uses the same Hive metastore. If you create any tables, if you do anything, the same way your Impala runs on top of the same Hive metastore, here also Spark SQL is just one another add-on or a layer on top of your Hive metastore. Okay?
So essentially, Impala then, sort of, right?
Correct. A sort of Impala only, correct. You can say. Yep. Yeah. And yeah, to be even more frank or to be practical, more practical on the Spark SQL, this is not even as much rich features or rich commands as Impala also, I can say, because Spark SQL got introduced from Spark 1.0 release onwards only, from last 1 year or 1.5 years itself. And Spark streaming came into existence into Spark from last 1.3 release onwards as well. Meaning from last 8 months or 9 months back. Prior to that, there was just some incubation stages were there. So I mean, these are their ages, or I can say this periods that when they got released.